they don't like to open it up to the outside world. But using that router, it can send its data to EvoHome or Honeywell's cloud servers. So all the information out of these radiator valves, etc., can be sent to the cloud server, so that whenever I talk to it through my app, you don't actually talk direct to the house, you talk to the server. You request of the server, can you just tell me the temperature in this room, or temperature in all these rooms, to get it. Now that's the sort of thing that you'll be doing in the lab this week. This week you'll be writing out to the cloud server into a database. Next week you'll be adding an Android program to start interacting with that server. So you'll have that basic sort of system there. Now, EvoHome, not a sort of, not great developing my own sort of view, because they've not really released this programming interface to the outside world. You can probably guess at it, and people have guessed at it and sniffed out the traffic and found out what the commands are, but they've not made it public so that they don't say, look, we're not going to change it for 2 years or something like that to it. You can simulate it, you can sort of send these messages still, but they may change the API without notice for it. But the messages sent to and from the hub are actually in JSON format. And again, that's the thing that we'll be doing in the assignment. You'll be sending messages around in sort of JSON to say, well, what's the temperature of all these rooms, what's the status of the valve to it, what's the layout of the house, what rooms are available, that sort of thing. So it does it over HTTP, sending these JSON commands. There's another little application, just to show you. Something here called a flick button. I'll just swap that window over. This is another type of node. In this case, it's just a little internet button. Amazon do a version of this that's got bigger batteries in and a good Wi-Fi connection. This is by a company called Flick, F-L-I-C, for it. It communicates using low-power Bluetooth to talk to things, and it uses your phone as its hub. So it sends a message and it detects a single click, double click, or a long click. The sort of things that you might do with a sort of mouse. And either sending the message through your phone as the hub, which then connects to a router somewhere, and hence off and sending messages out over the sort of internet. Or they also sell a hub so that you don't need to communicate through that, and it can just send it off as needed. Now, just to give you an idea of what this can do, because it doesn't sort of sound too much initially. This flick application, for example, here, that's controlling this little blue flick that I've got. Allows you to program the click, the double click, or a long click. So, for example, if I do, and I'll bring up the camera on this. Just do a single click on it. You'll have to take my word for it there. I did a click, and there. It says, well, hopefully one of those should have been the. Is that top left one? Is it out of focus somewhere? Try it again. See if I can get one in here. All right, so I've got a little bit out of focus, so I think I'm doing in a bit of a rush to it. Just
Yeah, so when it's actually registering, it's gone through.
It says here a double click will cause a sound to come out. Sort of thing but you can program the clicks to do whatever you like with it. There's a whole set of little applications going through. I'll leave you to discover what it can do. One click, double click, or a long click. Some of you might have seen what the long click does. All right. That was a long click. Somebody's got to be tempted by the long click for it. So in the actual code, you can in the application, you can decide what you want to do with each click. Now in this case, you haven't taken a photo, generated a bit of sound, but you can again have it turning on your lights, turning on your heating, drawing your curtains, whatever, and it means you can have that done wherever you like. Now where all this fits in, thank you, I think I didn't know whether it was a good idea to leave that long click in there. Where does this fit in with the Internet of Things? As I say, we've got there a couple of examples of nodes for it, and they fit in with the generic sort of hardware platform falling under what we call this node architecture, how things are put together. Now I'm just going to have a quick look at some sensors and actuators, the sort of types of it, and then we'll move on to next week, really, their communication architecture, how you get these things talking. So, sensors and actuators, as you've sort of found out in your lab, dotted around your house, might be sort of temperature sensors, motors, turning on lights, turning on your air conditioning. You might have a motor that opens and closes a window or whatever, wearable ones, all that sort of thing to work with. And we're going to look at what makes something a node and what makes it just a general sensor on its own. Now I'm going to have to turn that sound off, yeah. The general idea of a sensor node is some processor that's linked up to sensors around. Whether it's... Oh, you can have the amusement back on in 10 minutes. General idea of a sensor node. Yes, it's connected to sensors in the outside world, pretty much like you were doing in the labs, where you've got a PC connected to these sensors, but they're then connected, possibly through a gateway, to the outside world. Now that gateway is the difference between connecting, your PC isn't always connected direct to the internet, your PC talks to, say, a router, and then from there to the outside world. Well, it could well be that your sensor node doesn't have enough capability to have a straightforward internet connection, and what it has to do is talk to one of these gateway nodes that can talk to a router. Now this is the equivalent of that hub that we have that I just mentioned for the Evo Home setup. The hub where all the radiators all talk to a centralised gateway, and that can then talk to the router, which can communicate with the sort of outside world. The reason why that top sensor node isn't connected directly to the internet, well, it probably wouldn't have Wi-Fi on it. Because I'm sure you're aware of if you keep your Wi-Fi on your phone, it goes down over the day, something like that. You get about 10 or 12 hours Wi-Fi usage out of your phone before you have to charge it up again. If you can walk around with a power connector all day, you're fine. And that's why your laptop's okay for internet connection, probably for about 4 hours before it sort of dies down. Desktops, which are plugged in, then you've got that permanent thing. So in order for these to communicate, you've got to use something that's less power than Wi-Fi. Now that's what we're getting onto next week when we look at things like Zigbee communication, low power Bluetooth, etc. to work with. We're just looking here at what's actually connected to the node itself inside it. Now the node typically has sensors and actuators connected to it. Now I'm not going to go over all the different types of sensors because they're just a collection of pretty, I wouldn't say necessarily boring facts or whatever, but they're just things like light sensors, movement sensors, acidity sensors, radiation sensors. Whatever's happening in your environment typically has got a sensor associated with it. Some of which the sensors are sort of omnidirectional, they're picking up things from all around, like a microphone. Some might be narrow beam, like sending out a distance sensor, it just sends out a signal and bounces it back to find the distance. Some might be active sensors, broadcasting out again in a wide range, and picking it back up. But that's basically what we mean by sensors. But it's the role of a sensor. It's a role of whoever designs these sensors, the electronic engineers, to turn that detection of something in the outside world into an electrical signal. Now, this is the area that we don't normally have to deal with. We're on an application development course. We're not really on electronic engineering, so we're not building our own sensors that can take light and then decide how much electricity is generated by that and then build something to sort of send that out. That's up to the electronic engineers to supply us with these sensors. So when you're using your fidget kit, they've been designed by somebody, electronic engineer, to send out these signals to it. Or you can use your Arduino kit, whichever. But typically they use something called a transfer function that will have something that's physically measured in the outside world, like the brightness in lux or whatever they measure it in, or sound in decibels, and they'll use some sort of transfer function to generate an electrical output, and that's what you're plugging in the lab. You're plugging in that wire, and it's sort of, you remember you got that voltage that went between about 0 and 5. It's this